Welcome back to Balu Design. In this video, I just show the 3 to 1 principle. As per the 3 to 1 principle, how the pod file will be constrained. And just to show that what is that approach of 3 to 1 for that whole entire process. So I just explore this profile first, all the datum simulators. So now I just explore that one. So in this condition, we are explorer we will showing. Now just prefix the pod file. So now you can see this as per the 3 to 1 principle. Just remove for that all constraint. Now I show that this is a pod, the pod within the datum profile. In this datum profile, we have a constraint. Now you can do constraint this datum. Before the datum you can fix. Now you can check the whole entire degree of freedom is there. At the pod level, we are considered only for the negative direction we are consider. So total 3 rotation, 3 translation is there. So now we want to fix this as per that constraint, this pod. Now I just constrain that primary datum. So as per the 3 to 1 principle approach, now you can see the pod will be confined. So that to translate, remaining is there and one rotation is there remaining. Now we want to constrain another secondary datum. The secondary datum approach, I just show that how it is happen. So the secondary datum already fixed at the pod. Now I just given a constraint. So now you can see the pod. If you can give the pod, if you can check the degree of freedom. So the pod have only translate. There is one translate is that the whole entire rotation will be arrested for this primary and secondary datum. So no rotation is there for this profile. Now you can go to that tertiary datum. The tertiary datum, just to see that, I just show the tertiary. That also we want to fix. So it will fix it. Now you can go to that tertiary datums. You can check the degree of freedom. There is no degree of freedom. The part is fully constrained. But that is only for the 6 rotational and 6 translational. It will not constrain. So only for that approach, the port level, we are constrained 3 translate and 3 rotation. But remaining, I just explained the PPT. You just easily to identify understood how the entire process work about for that. This approach you can easily to identify purpose. I can do that. So this is an X. You can see to that. So the first slide it will be showing for the vehicle coordinate system. As per the vehicle, it was coordinate within like this process. There's two kinds of scenario it will follow that in globally. So at the time you can transference rule and the longitudinal rules. This is only for the horizontal motion it will happen. For the vertical motion is the axis. That why that coordinate system that all the part will be constrained on single coordinate within every part you're going to decide that's into the components the part want to constrain within a single coordinate system. As per 0, 0, 0, x0, y0 is a 0. We want to constrain the whole entire part. So otherwise it will be it will be difficult to complex assemble. So that the complex assemble we want to constrain one single coordinate areas. Any kinds of part it will be developed like that single coordinate system. So this is easy to assemble the part and don't have any problem in features for that manufacturing wise and assembly wise. That's why the coordinate system follow for the globally. For the OEM to OEM, the coordinate system, some small different it will happen for the vehicle coordinate systems. So it will take in whole layer inside of that one. In take the center of gravity will be taken to approach that one. Yeah. In now you can see this total degree of freedom. What are the total degrees of freedoms as per the vehicles? The vehicle per the vehicles. So in this case, we are have seeing the two similar vehicles. One is like aircraft, and another one is car. This is an automotive car. It is aerospace and different and car is different. But all that approach pitch rule, this and all it is similar for that. But what the difference between that in vehicles? As per the vehicle, we have a road of contact is there. But at the initial stage, road of contact only available in aerospace. After we don't have any approach. So always the y direction, up and motion direction only yaw is there. And the way forward is rolling is there. And the x left and right will be have up pitch. So pitch will be only whenever the load act of the body movement will become upward of the vehicle. It is called the pitch. The rolling, roll and yeah, is totally different. And the same process, but total degree of freedom we want to following for the aircraft, but much more accurate process we want to do for the aircraft and the aerospace process. Not in automotive domain, small different couple with it's complicated with an aerospace domain. So now we can go to the 1D and 2D. 3D. What the 2D 2D? It is a visually For that 1D is have a two, it's like a point of contact within the two single lines. It will have a, it is like a 2D, it's like in a surface, and 3D is a three-dimensional of contact. It will be showing the whole entire visibility. Actually, the whole entire process we are approaching for the 3D visualization process. This is for visualization and for that part level process also. For the physical part also, you can to see like this only. As per the 3D component that current scenario easily understand purpose, we are doing the 3D modeling for the entire vehicles. The predefined design on the process. So now we can go to the in vehicle design. As per the vehicle design, we have the two types of approach. One is the top down, and another one is bottom up. Yeah, top down approach started by defining the overall concept and major parameters of the vehicle first, then the breakdown into the small components like chassis, engines, and a body design. While a bottom up approach being by designing individual part separately and then assemble them together to create the final vehicle structures. Essentially, top down focused on the big picture first, while bottom up focus on individual components instantly. So easily to understand what I will say for this one, the vehicle design process. As the design process in another one, as a design process, the top down, the breakdown of the vehicle into the major subsystems in top down, chassis, powertrain, body, and then future refine each subsystems into the smaller components, ensuring the overall coherence and aligned within an initial design goal. As a bottom up design, individual components with detailed specifications that integrates them into a large assemblies, potentially landing to adjust and optimizing later to achieve the overall functionality. So this is the design process for top up and bottom up approach. So you can see this easily to understand further what that being top down and bottom up. Why I will take in this one means if you can approach any constraint, any process, it will be doing before development designs. It will be predefining to design for the overall vehicles. That is the initial stage of process we can to follow to design. So now the 3-2-1 principle approach for the part level. I just showing that part is free state, part without constraints. So the total 3 rotational and 3 translate is there. So this is a free state condition. Now we can approach for the 3-2-1 principle as per the primary data. The point of contact is 2 is there. So the 2 rotational and 1 translation degree of freedom is constrained. There are 1 rotational and 2 translation degree of freedom is remain. And the secondary process, the secondary datum 3 rotational and 1 translation degree of freedom is constrained. There is 1 translate degree of freedom is there. And the final one tertiary datum, there are no degree of freedom, it will constrain properly so that all the degree of freedom will be constrained for this port level. So this is a port level approach. At the next slide, I will show you for that the vehicle coordinate system, the whole entire degree of freedom how to constrain process. Now we are detailedly explained for that the 3-1 principle. As per the 3-1 principle, that this is a positive x and minus negative x and a positive y and a negative y, positive z and a negative z. So in this case, the dy of x positive linear, it is movement is possible or not. We check that yes positive, the movement is possible. As per this part, it will be movement slightly from here and there. So that longitudinal direction and the y direction also the transparent direction it is it will translate. So this the position will possibility is that and is linear. In this is linear also in minus it is not in minus the positive direction not possible, but in negative in positive direction it is possible, the negative direction is not possible. So in this case only I show you for this one. So that x clockwise, that x clockwise and x anti-clockwise. That x clockwise you can see the rotation for that not possible. So if you can rotate a component, it is not possible for the x clockwise and anti-clockwise also it will be like that. And y clockwise also the same similar process and anti-clockwise also similar process. But in z direction, this possibility is there. So the two things it is possible for the z. So the movement will happen for the z direction. But x and y it is not possible. So the part will be not movement. So these are the things easily to understand. So the primary datum 5 degree of restriction is there. So this is a 5 degree of freedom. So is a negative linear and x clockwise and x counterclockwise and y clockwise and y counterclockwise. These are the approach. It is not possible. 1, 2, 3, 4, 5. This is a primary datum restriction. Now we can go to that secondary datum. As per the secondary datum, I just showing for that visually. So you can easily to understand for purpose you can make this is what this one. So now you can see this part you can to translate from here to there for the x and y direction. But in z direction positive it's not possible. So I just mentioned that linear is not possible. And y negativity is y negativity is possible is there. Then is a direction also as a linear. It is possible is a positive. Is a negative not possible. So these are the complete rotation. We already see this approach for the design one. The same things it will be showing. It full rotation will be arrested and one linear direction also it will arrest for this area. So the two linear direction will be arrested. So remaining all rotation will be arrested. So total 6 plus 2, 6, 7, 8. So the 8 degree of freedom. Secondary datum, the 8 degree of freedom is restricted. Now we can go to that one. This is a treasury. The TDTech datums, you can say that multiple name. Primary and secondary, we now see the treasury. So that datums, you just see that x positive linear, x positive negative. In this approach, we can do movement, it will happen for this direction. but this direction will be restricted. So I just mentioned it's not possible to move. And why linear also it is not possible, and why negative it is possible is there. So in this direction it is possible, and Z. So that Z positive linear it is possible, and that negative linear it is not possible. So this one only I just use for concept. So these are the way you can approach for that. The is a positive linear it is possible. Here a negative linear it's not possible. And all that already the secondary datums all rotation will be error. Same should will be followed. Additionally, we can constrain for that linear direction only to constrain the port. So now minus x only it will be restricted for this area. So additional one translate will be constrained. For now the tilted datum 9 DOF restricted. So whenever the port at the 12 degree of freedom, any individual components you could constrain. Only for that 9 degree of freedom only you could constrain. Remaining a possibility is not there. So in this area there is a positive and a y negative and the x positive. These are the direction. As per that component keep form that alignment of the data features. But now these are the opening processes that whenever that using a chicken fixer, the holding purpose we are using for that any one of the clamping force to attach the port to clamp that the free state of area as per the requirement. So this is approach you can easily to understand purpose. I make these videos. Thanks for watching. For more updates, like, share, and subscribe my channel.